Thank you, Julia. Hi, everyone. As Julia said, my name is Tim Hendricks. I'm the CTO and co-founder at Styra. And here we're going to be talking a little bit about microservice authorization, especially in the context of zero trust. And so the sort of jumping off point here for what I want to talk about is really just a very simple observation, which is that all these megatrends that we're all seeing, that we're all participating in, around DevOps and a move to microservices and a move to automation, self-service, cloud, CI/CD pipelines, all of those mega trends are fundamentally changing how we're building and running our software. And we all know that. We all realize that. What I want to point out, however, is that a lot of the security that we have to put in place for those new applications, for those new platforms, for those CI/CD pipelines is necessarily changing because of all those changes in processes. And so if I think about, from a security point of view, if I think about the shift toward microservices, what I see roughly is like a huge increase in the number of APIs that we now have to protect, right? And if I had to pick a number, maybe it's 10x, right? Because every one of those little microservices was designed to expose an API. And now from a security point of view, that's something that we need to protect. If we think about the move to cloud, one of the ramifications of cloud is that we fundamentally just have no control over the physical hardware that we're running our software on, right? We can no longer just unplug a network cable as a security measure if we so desired. If we think about CI/CD and automation, what we're really thinking about is we're deploying those applications that we're building routinely to data centers located all over the world, right? And so no longer can we sort of assume that there's a fairly static environment into which we're deploying our applications. And what that means is that we no longer want to be relying on the environment to protect, to secure those applications. And then if you think about DevOps and self-service, the observation there is that, well, we've just got more people who are responsible for operating a production environment than we did in the past, right? When we had a dedicated dev team and a dedicated operations team. And so zero trust, in some sense, is a great way of mitigating a lot of these security concerns for these new cloud-native approaches to software design, implementation, and operations. And so when I say zero trust, what I'm really talking about is I'm talking about really the AAA of security: authentication, authorization, and accounting. And my take on zero trust here is just that security, those three things at the very least, should follow all the services. Those things should not only be implemented at the edge. Those three things should be implemented should follow each and every service. And so, what I want to call out today is really thinking about authentication, authorization, and accounting on each and every API. And so when I think about APIs, I'm talking about the APIs that are coming up because they're externally facing for that application. Maybe they're internal APIs that are only used between services. Maybe they're even third-party APIs like we're using on the public cloud or our CI/CD system. So my belief here is that all those APIs, regardless what software system they're running on, should be secured using that AAA paradigm. And then I think once you do that, that mitigates a whole lot of the concerns, right? Because what you have put in place now is you have controls over each and every API, over each and every action that gets executed on all that software across your software stack. And so all those internal APIs that we have for microservices, you've got controls over those. All the public APIs that you're using to implement your cloud, you've got good tight controls over those. All your CI/CD pipelines, you've got good controls over when applications get deployed, what environments they get deployed to, and so on. DevOps and self-service, once you've got authorization in place, it's fine to have more people with access to production because they're limited to, in a least privileged sense, only performing those actions that they should be able to perform at any rate. Now, we're going to focus today on authorization. So remember, authorization is a problem of controlling actions that get taken. So those actions could be taken by end users, by people, or those actions could be taken by machines, by services. And so today we're going to sort of encompass both of those, and we'll see examples of that. And I want to just contrast this very quickly with authentication. Remember, authentication is the problem of how do you convince a computer system that you are who you say you are. So that's usually solved with usernames and thumbprints and passwords and MFA and the like. Today, we're going to be focusing on authorization. So can Alice withdraw money from an account? Can Bob query the production database? Can this service request invoices from another service, and so on? So when I think about the application, when I think about building these microservice applications, yes, it's the case that in the old world, the monolithic world, we had a handful of different components that made up the application, the gateway, the front end, the back end, the database. And in this new microservice world, we've got many, many more components. But what I'd argue is that that all those different components in the microservice architecture can be still lumped into some of those same categories of functionality that we had in the old world. And that's what I've kind of tried to draw here, which is if you think about a microservice application, you can still break it down into the gateway components, the back end, the front database. And so what I want to call out here is the role that each of these different collections of components play in the overall in the context of authorization. So if you think about the gateway is a wonderful place to enforce API authorization for external, for customer-facing, for user-facing APIs. If you think about the backend, that backend is really responsible for enforcing, maybe at a finer level of granularity, those external-facing APIs. But the backend is also responsible for, and the only place to enforce authorization controls over the internal APIs within an application. Why? Because those internal APIs simply don't go through the gateway. If you think about the front end, well, the key thing that the front end is going to do is it's not going to really enforce authorization policies, but nevertheless, it will be responsible for understanding those authorization policies so that when it renders the GUI, that front end can make sure that it's not showing the user a trash can icon, for example, when the user is not authorized to delete the resource. And so the knowledge of that authorization policy is really important for the front end to make the application have a great user experience. Additionally, the front end, especially for multi-tenant applications, ends up helping those administrative users actually set up the roles or the permissions that their end users have within the application. And then if you think about the database is another great force to think about enforcing authorization. Obviously, well, we've done this forever, making sure that only the correct users can read the correct rows and columns from our databases. And of course, then the database is being used to store attributes that inform authorization decisions. We're going to look at the back end today very quickly. So when we think about putting authorization controls in place for the back end, there are really a number of options that we can consider. So remember, the idea here is that every time a backend service receives an API call, we want to put an authorization policy in place so that we have good controls over those APIs. So one option for doing this is you simply hard code those authorization policies into each and every microservice. Now, this is great from an availability and performance point of view. These things are going to run super fast because they're just written in Java, if the service is written in Java, or Ruby, or Go. And it gives the app developer a great deal of control over exactly what that policy is. There are a number of drawbacks, obviously, here. If you've copied this, if you're trying to repeat this authorization policy in all your different services, you've got to repeat that work. You've got to re-implement in every language you're using. The policies can therefore become inconsistent. Enforcement can be inconsistent because at the end of the day, it's just really up to the Microservice developer to make sure they're calling into that authorization policy at the right time. Security reviews are slow here because now the security team has to review each and every service. There's no way to really hot patch. There's no way to update that authorization policy without redeploying the microservice. And then logging. This was an interesting one that I heard from a CISO a while ago, and that was that from a CISO's point of view, they've got hundreds or thousands of these different services written by dozens of teams. And now imagine that you're responsible for hooking all of the logs up into a SIM so you can identify things like when a breach is happening or when it's already happened. And what that means is that you've got 100 different logging statements that all describe when an unauthorized access has happened. And so now you've got to sort of canonicalize all those, generalize all those so that your SIM actually understands what an unauthorized access is. So let's look at another option here for implementing authorization on the back end. So one of which is you could just do the microservice thing, factor that authorization policy, that authorization logic out into a dedicated microservice. So here the idea is that every time a microservice needs a decision, an authorization decision, it goes ahead and hits that authorization, that dedicated authorization microservice. There are a number of benefits here. You're not repeating work, right? You've got one place to implement those authorization. Policies are super consistent because there's one place after all. Security reviews are much faster because if security only really concerns about that authorization policy, they know exactly where to look for it. Hot patching is pretty easy. You can just update that authorization service. Number of drawbacks here, though. The biggest one that I'll call out here is really availability and performance. So if you think about a microservice architecture, one of the things that you'll end up seeing is that an end user request might hit, let's say, 5 different microservices. Every microservice hit incurs a network hop cost, and that's going to impact availability and performance. If you add to every one of those backend services a second network hop in order to check for authorization, well, now you suddenly double the number of network hops. And that can drastically negatively impact your availability and performance globally. Okay, so let's look at how we might address that. Well, one option is you turn that centralized service into a distributed service. And so now what you have is, instead of that authorization service running on a separate server as each of the microservices, now you distribute it. So you've got an authorization service running on the same server as each and every microservice. And what that does is it eliminates that network hop. But nevertheless, because it is effectively a distributed implementation of that centralized service, you still have all the benefits that you had in the last slide, or sorry, in the last option there for the centralized service. You don't have to repeat work. You've got fast security review, so on and so forth. The downside here is, of course, now you've got to take a dependency on this sort of distributed authorization service. Let's look at one final option here, and that is the service mesh. And so the service mesh has the nice benefit. The way that the service mesh works is that now you run the service mesh, which means you've got basically a network proxy running on each of the microservices. You've got that network proxy responsible for receiving and sending all of the APIs to and from the microservice. And so what you can do is sort of integrate that microservice with that distributed authorization service. And in so doing, you eliminate a lot of the drawbacks that we've seen in the previous option. So certainly here you've got one place to implement policies, so there's no repeated work. The policies are consistent. Security reviews are fast, and you can hot patch pretty straightforwardly. Availability and performance is great because now you've got authorization decisions being made on the same server as the service itself. You've got consistent enforcement now because you've actually integrated that service mesh with the authorization system itself. So now each and every request that goes into or out of that microservice can automatically, by the network proxy, go ahead and send that request over to the authorization service. And finally, you don't have to modify the service at all. The service doesn't even need to know that authorization service is running out there. Of course, the downside of this, or the drawback here, is that you need to now deploy the mesh. But if you're doing that anyway, then this is a good solution. Okay, so hopefully that gives you a sense as to some of the different options that you could use to sort of implement authorization for back-end services. And so I did want to zoom in a little bit on this last one, this service mesh, and call out the fact that, let's put some actual software names on there. So, Kuma is a great way to think about putting a service mesh in place. And what you can also do for this authorization system is use the open policy agent. And so here, I'll just talk through this quickly to make sure we've all got this covered. So the idea here is that what you're seeing here in this big dotted circle is the server, right? So this is the one server. You've got your microservice running on it. That's an instance, obviously. And then you've also deployed the Kuma data plane and the open policy agent, all on the same server, right? So now what you imagine is that there's some request that comes in from the outside world that goes into the Kuma data plane. You usually set that up via like IP tables. And so now Kuma receives the incoming request. What you can do then is hook up Kuma to the open policy agent. You can have Kuma send the open policy agent an authorization query that says, hey, is this API call authorized or not? OPA returns that authorization decision. Kuma is then responsible for enforcing that decision. So either Kuma, if it's rejected, will return, let's say, a 403. Otherwise, if OPA says that this API call is authorized, Kuma will go ahead and forward that request in step 4 back to the microservice. The microservice will receive that, as it always would, and then it'll construct a response, and that response back to Kuma. Kuma will go ahead and forward that back to the caller. So that's kind of the flow of how information moves in this world where you've got a service mesh deployed and you've got an authorization system. And obviously here we're articulating how to do this with very concrete systems, Kuma and the open policy agent. Now, once you've put that in place, the question is, well, now what kinds of policies can you write? And here I'm thinking specifically that you've got Kuma with OPA deployed. And so here are a couple of examples. Remember at the beginning, I talked about how we could have service level policies, which is controlling which service talks to which other service over which APIs. There are also user level policies to control which end user can perform which actions on or which APIs. And so, and then there's, I'll get to this external data in just a minute. So if we just look at the service level policy, here I've simplified it a little bit, but the idea here is pretty simple. This is sort of OPA's language for expressing policies. What you'll see here is that you're writing a very simple allow statement that says, you know what, allow a get on, I guess I'm assuming here that the application is a pet store. So allow get requests on the path/pets if the, and here then you're looking at the source and the destination for those service identities. And you have to decide on how you're going to deal with service identities. It's not something that I'll cover today, but there are well-known solutions for that. If you want to look at the user level policies, again, looking at the policy itself here, what you're doing is, again, you're writing an allow statement. Again, you're going to say you're going to do a check on the method, you're going to do a check on the path. But this time, instead of looking at the headers for source and destination, you're going to look at the token. So what a lot of people do is they'll go ahead and for authentication, they'll use JOTs, so JSON Web Tokens, to go ahead and communicate the user attributes throughout the service mesh. And what you can do then is hand that claim over to OPA and actually have OPA and write policies that allow OPA to sort of inspect the internals of those JOTs in order to understand what claims show up in the tokens. All right, so there's, you've seen service level policies, user level policies. I won't go into detail here just for time, but one of the other nice things that you can do once you have that deployed is write policies that rely on external data, so data about what's going on in the world. And so here you could use, you know, LDAP for employee information, or you could use any kind of really external data that you like. Okay, and so now what we've done is we sort of looked at how OPA can be used along with Kuma to implement API authorization at the service mesh level, sort of for backend services. But one of the other things that, remember, I articulated was that really authorization is not just a problem for the backend, it's a problem for that needs to be solved at the gateway and the front end of the database. And so the other thing you can do here is think about, well, how would I implement authorization for the gateway? So one option that you could go with is if you're running, let's say, Kong for your gateway, you could go ahead and connect that to OPA as well, so that you could enforce API authorization at the gateway level. This is one of the nice things about OPA and what it was designed to solve, is that you can go ahead and use OPA for really any use case that you like. OPA is not tied in any way to Kuma. It is a general purpose policy engine. And so a lot of people ask the question, well, then how does OPA work if, in fact, it is this general purpose solution? So I'll go through this very briefly. The idea here is that you have some service that decides it needs an authorization decision. That service goes ahead and sends a policy query to OPA, as you saw in the diagram a couple of minutes ago with Kuma. OPA returns a policy decision to that service. Now, the service is responsible for enforcing the decision. OPA, however, is responsible for making the decision. So we already saw that with Kuma. But a couple of the key things as to why OPA can be used for all these different use cases that you saw in the last slide are shown here. So one of which is that policy query is really just an arbitrary chunk of JSON. OPA doesn't know or care what a method, a user, or a path actually are. It wasn't built into OPA. There's no Go code in OPA that understands what those things are. And because of that, I, as a policy author, well, I know what a user, method, and a path is. So when I wrote the policies that I showed you a couple slides ago, I can write the policies to do the right thing. The other thing that I'll call out here is really that policy decision. The policy decision that OPA returns, again, yes, it can be used to return allow deny decisions to give you straight up authorization, sort of classic authorization, but you can also return arbitrary JSON values again. This is really useful because when you're integrating with, let's say, the Kuma data plane, you might return not only is this request allowed or denied, but what's the status code? Or maybe what are the additional headers that need to be passed along to the microservice at the back end? Okay, well, now I've talked a little bit about how OPA can be used across all these different components of the application, but why stop there? OPA was designed to solve the authorization, more generally the policy problem, across the cloud native stack. We focused so far on the application because that was where we started, but really OPA is being used across the stack to solve authorization and more generally policy problems at what I like to call the three pillars of cloud native, which are CI/CD pipelines, the platform that we're running applications on, as well as the applications themselves. So you see on this slide, you see sort of the one we always show to people about how and where OPA can and has been deployed in production. So each and every one of these categories of use cases, we've seen people deploy OPA in production to solve authorization policy problems. We've talked here about the sort of application or the service mesh level, the gateway level. Using OPA to do admission control within Kubernetes is another popular one. I saw an earlier talk in the agenda for that. using OPA like within a CI/CD pipeline is pretty popular, especially around using it with sort of to control what Terraform resources or what resources on public clouds get deployed with Terraform. We even see people use it for like SSH control as well. So the last thought I'll leave you with is this picture is, I think, pretty good in terms of what you get with OPA. Like in a service mesh setting, you may have 500 instances of your microservices split across all kinds of data centers. And so if you've got 500 instances of your microservices, what you end up with when you're running OPA as a sidecar, just like you would with the Kuma data plane, you end up with 500 copies of OPA, each of which need to have policies deployed, each of which need to have status updates, each of which you need to write policy for. And so, at the end of the day, what you do need to add to OPA is a control plane, a way of understanding and controlling all of those OPAs. And so one option for this is what we call Styra's declarative authorization service. It was designed from day one to be a control plane for OPA. It can be used to control OPAs across all these different use cases. It has specialized support for Kubernetes and for the service mesh. And so I definitely check it out. There is a free version that you can sign up for. So definitely check that out if you can. The way I always like to think about it is it is that control plane, but what it provides is really a vertically integrated policy as code solution that was really designed for the enterprise. So go ahead and check that out if you can. Shameless plug here for sure. Okay, and I think that with that, I will open it up for any questions you might have.
Thanks, Tim. It looks like we have a couple of questions. We only have a couple minutes left, so we might not get to all of them, but I'll ask one. We have one from Colin. How do we authorize protocols like MySQL or any other app talking plain TCP and not HTTP?
Yep. So really the enforcement question that we see is the way to think about using OPA is that you would run it next to a service that knows how to handle like decrypt or not decrypt, that knows how to like pull out the interesting bits out of whatever protocol is being used. So OPA is not designed to like watch network protocols and figure out that this is a SQL connection or anything else. So this picture that we have here is pretty accurate, which is that the way you think about this is that the way you think about OPA is that you'll go ahead and connect OPA to something that is responsible for that has the domain knowledge to make those decisions. So in this example, one thing that you can do that's a bit different is that you can have OPA translate the policy into think of it as additional where clauses that can then be spliced into those SQL queries. OPA doesn't itself know about SQL. You need something sitting outside of OPA to actually orchestrate that.